In this project, we will learn about 7-segment displays and how to interface them with your Arduino. These components are a handy visual aid that you can incorporate into many Arduino projects. We will be making a digital dice using a 7-segment display and a button. To roll the dice, simply push the button and we will randomly get a value between 1 and 6 which would be displayed, just as if we rolled a physical dice. Ours will be a digital dice, and after building it, you can even use it with your board games. Let's take a look at the objectives. By successfully completing this project, we will have mastered the following items. You will understand how a 7-segment display works and how to connect a 7-segment display in a circuit. Also, you'll understand the difference between a common anode and a common cathode 7-segment display. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, 7 220 ohm resistors, a 7-segment display. We will be using a common cathode display, but if you have a common anode, this will also work as well. There may need to be slight wiring changes, a push button switch, and connecting wires. Let's first address how 7-segment displays work. If you look at the schematic for a 7-segment display, you will see that each segment or individual piece that has to light up to display a part of the final result has a letter and a corresponding pin that is associated with it. If we orient the 7-segment display with the decimal point at the bottom right, the pins are numbered 1 through 10 as shown. 1, pin 2, 3, 4, 5, and then at the top 6, 7, 8, 9, 10. If we look at the 7-segment display in a more physical representation, here is pin 1, 2, 3, 4, 5, and then at the top would be pin 6, 7, 8, 9, and 10. Now, each pin also corresponds to a particular segment on the display. So let's take a look at pin 1 for instance. Pin 1 corresponds to segment E. So if we were to apply 5 volts or a high voltage signal to pin 1, then segment E would light up. Similarly, let's look at pin 2. As you can see, pin 2 corresponds to segment D. If you were to apply a high voltage signal to pin 2, the D segment would light up. If ground or 0 volts is applied to pin 2 instead, then the D segment would not be lit. Get the picture? Let's say we want to display the number 2 on the 7-segment display. How would we accomplish that? Now remember, 2 would look like this. Okay? So in order for 2 to be displayed, segments A, B, G, E, and D have to be lit. So this would mean that we would need to apply 5 volts or high voltage signal to pins 7, which would correspond to segment A, pin 6, which would correspond to segment B, pin 10, which would correspond to segment G, pin 1, which would correspond to segment E, and finally pin 2, which would correspond to segment D. Let's quickly discuss the difference between common anode versus common cathode 7-segment displays. For a common cathode, which we will be using for our project, the common pins, which are pins 3, and 8 are connected to ground. This means that in order to light a segment or turn it on, you need to apply a high voltage so that the current can flow into the LED and then back into ground to turn it on. For a common anode, the reverse is true. The common pins 3 and 8 are connected to 5 volts or high. So in order to make a segment light up, you have to apply a ground or 0 volts to the pins so that current can flow through the commons, down through the LED, and down to ground to turn it on. So the difference between common anode and common cathode is the polarity of the common pins and the voltage you will need to apply to light segments. The datasheet for your 7-segment LED will tell you if it is a common anode or common cathode configuration. Let's take a look at our circuit diagram. For the first circuit, we are simply connecting the 7-segment display only. There's a lot of wiring with this particular circuit. So first, let's start at the extreme left. We would connect our 220 ohm resistors in the circuit. And if we start at the extreme left, pin 2 on Arduino is connected to that first resistor, and the end of the resistor would go to pin 7 on the 7-segment display. Similarly, for the second resistor, it's connected to pin 3 on the Arduino, and the other end goes to pin 6 on the 7-segment display. Next one, pin 4, then it goes to pin 4 on the 7-segment display. Next, pin 5 on the Arduino, that goes to pin 2 on the 7-segment display. Next, pin 6 on the Arduino, that goes to pin 1 on the 7-segment display. Then pin 7 on the Arduino. The other end of that resistor goes to pin 9 on the 7-segment display. Then we have pin 8 on the Arduino, the other end which goes to pin 10 on the 7-segment display. And again, since we're using a common cathode, pins 3 and 8 are grounded, and we connect that ground connection to the Arduino. So that's the wiring for our simple 7-segment display only. Okay, let's go ahead and wire up our circuit. First, if we take a look at our 7-segment display, if we orient it with the decimal point to the bottom right, you'll notice for the pins, this would be pin 1, 2, 3, 4, and 5. And then this continues at the top with pins 6, 7, 8, 9, and 10. Okay, so let's go ahead and put this in our circuit. I would recommend not to push this in all the way initially. In that way, we can actually see the pins when we are wiring up the circuit, because there's a lot of wiring in this circuit and we don't want to make any mistakes. So just gently push it in, and when we're done wiring, we could push it in all the way. I'd recommend putting in your 7 220 ohm resistors in the circuit initially. So I'll go ahead and do that. It's 1, 7. Okay. Alright, so let's start out wiring. So from the first resistor, it goes to pin 2 on the Arduino. So I'll make that connection. The other end of the resistor goes to the pin 7 on the 7-segment display. Right, so at the top, second resistor, pin 3 on the Arduino, the top of it, goes to pin 6 on the 7-segment display. Third resistor, pin 4 on the Arduino, top of it, goes to pin 4. Seven-segment display. Next one goes to pin 5 on the Arduino. Top of it goes to the pin 2. Next one goes to pin 6 on the Arduino. Top of that guy goes to pin 1. Next one goes to pin 7 on the Arduino. Top of him goes to pin 9. And the final guy, final resistor, goes to pin 8 on Arduino. And finish off with pin 10. Okay, so that's most of the wiring. Now we have to connect pins 3 and 8. So I'm going to put one jumper wire between pins 3 and 8 at the top here. And that has to be grounded. So I'm going to connect wire here, and I'm going to go to ground. On the Arduino. Alright, so now that that's complete, I'm just going to push in my 7-segment so it's firmly in place, and that completes our wiring. Okay, let's go ahead and upload the code. While that's uploading, I'll open up the serial monitor. So as you'll see, there's an instruction, enter a number between 0 and 9. So let's go ahead and start with 1. So I'm going to enter 1 here, press enter. As you can see, 1 lights up on our 7-segment, and I'm going to cycle through. I'm going to enter 2. 2 is displayed. 3, 4, 5, 6, 7, 8, 9, and then 0. Alright, so there you have it. Our 7-segment display is wired up correctly, and we're able to accept input from the user to display a number. When we get that input, we correctly display that on the 7-segment display.